Thank you very much. All right, so like the slide suggests, we're going to be doing a workshop on Scribble. And let me first give you a really brief introduction into me and Dimo, who will be giving this workshop to you. So I'm Joran, and I am a security researcher, product lead at Consensus Diligence, working on things like MythX and Scribble, for example, to make smart contracts more secure. Dimo also works at Diligence, and he's the mastermind behind Scribble. He's the main developer. So if there's any really in-depth questions that you have, he'll definitely be able to answer them. I'm going to be going through the main track of this presentation, talking about Scribble, talking about the examples in the workshop, and then Dimo's going to be managing the chat to answer all those difficult questions. All right, so like I said, we're going to be doing a Scribble workshop. And the structure of it is roughly as follows. I'll first give a brief introduction about Scribble, property checking, and that's just to give you the context that we need to go into the exercises. Then there's two main exercises that we'll definitely do, and depending on how long that takes, how long we're busy with answering questions, we'll have time for a third exercise, but we'll see. And then we're going to end with a small wrap up. Okay, so before we dive into Scribble, we need to start with properties. What are properties? We need to dive into properties because Scribble allows you to work with properties. So what is a property? Well, properties are logical statements that you expect to be true. For example, some cars are red, or there's some red in this slide right now. Another example is, which might be more familiar to you guys, is a function example only returns positive numbers. And the key here is that these properties describe statements that you expect to be true. So they might not actually be true. They are essentially assumptions that you have about a smart contract. And if those assumptions aren't valid, then that's usually a big problem, and vulnerabilities arise from that. So what do? You test or verify them. And that's exactly where Scribble comes into play. Scribble is actually two things. So first, it's a specification language for writing down properties, and then it's a runtime verification tool to actually work with the properties. So it's a specification language, which means that it is a language that you can use to write properties in. We've closely based it on Solidity, and you use annotations and you write your properties down as annotations. I have a little example here of a property that says that the function "this cannot be hacked" always returns a positive number. It has three parts. The if succeeds, which describes what kind of property it is, and in this case an if succeeds, so a property that must hold if the function executes successfully. Then there's a message, which is optional, which our tools use to report findings if they find a violation of your property. This is really useful if you have a ton of properties, because it will make it easier to find which ones are actually violated. And then there's a third part where we have the actual meat of the property. So here, result is compared to 0, checking that the result is positive, which is actually what's being checked. The second part of Scribble is that it's a runtime verification tool. So what's that mean? Well, it takes the properties that you've written and instruments them into the code. So it will inject Solidity code that actually checks those assertions that you have and raises assertion-filled events if they don't hold. What's nice about this is that because we essentially encode the properties as pure solidity, we get to use existing tools that do fuzzing and symbolic execution and use them to find violations. This is an example of what this instrumentation looks like. On the left, you see the original example, and on the right, you see how we added an assert statement at the end of the function saying that the result must be bigger than 0, essentially encoding the property. Now, this is a very simple example, but it does highlight the rough structure of what an instrumentation actually does. All right, so that's all for the introductory part. Now we need to do a little bit of setup before we can actually do the exercises in our workshop. So we need to install a few different tools, and I think one of the announcements already asked you guys to install some of them, so that should speed things along. But we're definitely going to need Scribble. Also, you can also install Truffle or use Truffle for this workshop, but it is not strictly necessary. And then we're also going to use Mithril and MythX. We're going to use these two tools to automatically find violations for the properties that we're going to write in this example to show you how you can actually make use of the properties you write with Scribble. All right, so this is all you need to do to set up all the tools. So it would be, let me type them in the chat as well, so that you can just copy paste, because copy pasting from slides is very difficult. And then we'll continue to the next one. This is the right project. I think I might need to go to the YouTube stream to actually write these down. Timo, do you think you could put these in the chat and then I'll continue to the next slide?
Yeah, go for it. I'll figure it out.
Cool, thanks. Okay, so here are some useful links that you can use after this workshop to dive deeper into Scribble, or maybe contribute to Scribble, or use the MythX platform. So the first link that you'll see here is pointing to docs.scribble.code, which is where our Scribble documentation lives. So anything that you need to know about running the instrumentation, running the Scribble CLI is there, but also everything you need to know about the specification language aspect of Scribble is there. There's a bunch of examples, so it should get you started pretty quickly. The second one is pretty simple. That's the repo where Scribble lives. So if you're interested in checking out the code, maybe contributing, go there. And the final link is MythX, which is the platform that I called out before. MythX uses a range of different analysis techniques to find the violations for the properties. And it's going to be a little bit more powerful than Mithril. All right. So the first exercise in this workshop is going to be about finding a bug in an Erc721 contract. I've set up a Truffle box and Git repo, so whichever means of pulling you prefer, you can use that, with everything that we need for this example. There's a README in there that describes all the steps of the workshop. So if you need to catch up or miss a step or want to redo the workshop, you can find everything you need there, and even more. So these are the commands that I used to get this exercise on my machine. It's also possible to just do a git clone. All right. So now let me actually share the screen I have with the code. Yes. Moving things around, share screen. Yep. All right, so I'm not sure how to actually make the screen appear now. Yes, awesome, thank you. Okay, so what we have here is a simple Erc721 contract, but it's slightly off, and we'll go into that pretty quickly. But it's a simple Erc721 contract. There's all the functions that you would expect: total, supply, transfer, approve, and in this case, there's something odd in the transfer function. Normally, what you'd see is that you first update the from balance, so the balance of the message sender, and then the to balance, so the balance of the recipient. But here it's kind of split up into 4 steps, where we first compute the balance minus the balance of the sender minus the value, and then the balance of the receiver plus the value, and then we set these changes. And there's something weird going on there, which will allow an attacker to actually gain some tokens in this contract, and we can find that by writing a few properties. So let's go ahead and do that. In this case, we're talking about, or I want to specify something about a function and I want to specify something about what needs to happen if it executes successfully. So I'm gonna need this if succeeds kind of specification. Also write a message so that later on, if Mitro or Mithx finds violation, I can actually easily see which property is violated. Let's see. Oh yeah, let me increase the font size a little bit, which should make it easier to see. Maybe this is a little bit too big. Yeah. Okay. So the recipient should get value added to its balance, which is obvious, right? Because if the transfer succeeds, the recipient should get money. So the balance 2 it must be equal to something plus the value that we send. Oh, what we actually want to say is that the balance after the function is equal to the balance before the function plus a value. So this is where we can use the old keyword that's in Scribble, which allows us to refer to the value of variables and expressions at the beginning of the a function instead of just at the end. Right. So what this property now says is that the balance of 2 after the transaction is equal to the balance of 2 before the transaction plus the value. Now, there is one case, and that's a really relevant case, in which this is actually non-valid. And that's a case where you I'm going to zoom in a little bit more. And that's a case where you send money to yourself. That's actually shouldn't happen too often, because why would you send money to yourself? But it is a case where no value should be transferred at all. So we're going to say that the message sender is not equal to the recipient. And only in the case that that's true will we check this. So that's all nice, and this will verify just fine because it's valid. Now, this case that we just described where you send money to yourself, let's look a little bit more into that. Because if you send money to yourself, then nothing should change. In short, sending money to yourself shouldn't change the balance. So let's say like message sender is equal to the recipient, in which case the balance of the recipient is equal to the previous balance of the recipient. Yep. We can even generalize this a little bit more, because what we can say is that in general, the sum of the both balances needs to stay the same. So if I send some tokens, X tokens to someone else, then my balance plus the other person's balance before and after the transaction should be the same, because we aren't magically creating tokens. That's called the property no magic tokens. All right, so this is gonna be old. Yeah, I need to use the right variable names. This is the same as if we before and after. And you might have noticed that these last two properties will catch the bug in this smart contract. But let's have Mithril actually find the bug. So the first step, once you've written a few properties that you want to check, is to actually do this instrumentation phase. This is where you'll need to run a Scribble command. So the command is as follows: Scribble arm-n files, and then the file that we want to instrument. There's actually many different things that you can do with Scribble and many different options. And we're just going to use this one for now. If you're interested in all the capabilities of Scribble, please check out the documentation, because there's a lot of useful information there. But what this command will do is it will take the annotated contract and do that instrumentation and replace it with the instrumented version. So we'll be able to see that. If I didn't make any typos in my properties, but I did. So what you'll see now, or what you see now in the terminal output, is that I made a mistake in using the variable name balance instead of balances. So it gives you some nice debug information telling you that balance doesn't exist. I made this mistake a few times. So balances. Okay, should be correct now. All right. So it's kind of managing the different contracts in there and making sure that everything is in place. So this is what you're actually seeing now is what Scribble creates. It's this instrumented version of the contract with the properties as assertions and assertion failed events. Downstream tools can look for these and find violations, and that's our next step. Because now I'm going to run Mithril on this smart contract to see if it can automatically break the contract, find a violation for one of these projects. So I actually made a script with the Mithril command that I'm going to use, which is in the screen right now. So let me start it because it might take a second or two. So the first word, myth, is to invoke the Mithril CLI. The second word says that we'll be analyzing a smart contract. Then this points it to the now instrumented smart contract. The -T tells Mithril to only look for one transaction deep, which is totally fine in this case because the vulnerability should be coverable within one transaction. And then this final bit tells Mithril to only take 60 seconds. So in this case, we have a pretty small smart contract, just an ERC20 token, and Mithril can cover everything just fine within that minute. But in other cases, you might want to give it some more time, give it a higher transaction depth so that it can actually appropriately cover the elements of your contract. And in the output here, we see that we found a violation, namely that sending yourself money shouldn't change your balance. This is the first property, and there's something really interesting happening here, which is that we don't see a violation for the last property. That's because by default, Scribble will insert both an assertion failed event and an actual assertion. What's interesting is in this case is that if property 1 is violated, then property 2 will also be violated. But because of the assert, we never even reach this, so it's not reported. I'm not super certain about the actual tag that you can use to remove these assertions, but Dimo will probably be able to put that in the chat. In any case, we found that there is a vulnerability now because we know that sending yourself money will change your balance. In this case, for the better, so an attacker would actually want to exploit it, which is nice for them, but not so nice for the developers. Now that we found the vulnerability, we obviously don't want to keep this annotated source code. Instead, instrumented. Instead, we want to return to the original annotated source code. So what we can do is really easily, we take this command that we use to arm the contract and we make it disarm. Running that will return us to the original state where we have our nice readable ERC20 contract and our nice properties. And now we know that this property is being violated, so we need to switch some things around in the code to make it work correctly. All right, that is exercise number 1, where we can essentially use a few if succeed statements to easily or find this problem. Now let's go on to exercise 2. So this is in the exact same location or a similar URL as the first Scribble exercise. Let me edit on the screen. So you can just do a git clone. Let's see if I can share the link really easily. In any case, you can go to this URL or just clone it. It's just https github.com consensus and then Scribble exercise 2, which we can clone. I already have it here. So let me just move over to that directory. And in this repository, we have the same situation. There is, again, a README that gives us all the information that we need to follow along for the exercise or redo the exercise after the workshop. And there's another contracts directory. So here you'll find a vulnerable Erc721 contract, which I've copied to a working sample so that I can make changes without modifying the original one. You don't have to do that. So this is, again, just a plain Erc721 smart contract. This is, I believe, taken from the Open Zeppelin implementations, and we made some small adaptations to make it easier to work with this contract in a workshop environment, but nothing really major has been changed. More specifically, what we changed is we made a function public that used to mint new tokens, which the internal fuzzer behind Mythex will use to create a state which is exploitable. Without that, the fuzzer will never be able to reach an exploitable state. So that's why it's in there. All right, so let me go straight to the code that I want to annotate for this exercise, which is the transfer function. No, it's a transfer from. One of the most commonly used properties in Erc721s, but also other tokens, is the fact that you don't want people to be able to send funds or specific tokens to the 0 address, because that effectively deletes them, and you might not want to support that. So we can easily write a property to check that that never happens. We'll use another it succeeds, and let's say never sends to 0. Now, it's also pretty easy to encode that as a condition, because we'll say that 2 is not equal to address 0. Now, in this case, you can see that the check is not there, and in a minute, I'll run a scan to actually automatically show that this property is violated. But let me quickly write up a few more properties that are relevant for this transfer from function. So we want to make sure that if we transfer funds to someone, or if we transfer a token to someone, that they actually are the owner of the token after the function succeeds. So to receive token. So there's a function in Erc721 called owner of, which gives us the owner of a token if we pass it the token ID. The transfer from will send the token with token ID from address from to address to. So we want to check that if the sender actually receives the token, then after this function, the owner of token ID must be equal to the to address. The other part that we might want to check is that the sender or the from address was actually the owner before the transaction. Then we'll use another keyword alt function call here again in a minute. But let me quickly try out a message. The sender actually has to. I mean, this is pretty important, right? Because otherwise we're able to not take tokens from anyone. So previously, in the state before, the owner of token ID must be equal to from. Now there's one more thing, because this is a transfer from function where it's not only the actual owner of the token that can transfer the token, it's also people that are authorized to send that token that can call this function. So the sender is authorized. So in this case, we want to know whether the owner of the token before the transaction is the sender or whether they have authorized the sender. Because we're going to essentially write a very kind of complex statement here with various clauses, we're going to use a let statement to essentially create an intermediary variable. So I want to store or bind actually but the old owner to this variable called old owner. Now I can write a condition pretty concisely that uses this variable. So the condition that I want to check here is first that either the sender is the owner or the old owner, or the sender is approved for this token. Which we can use the get approved function for. Ah, nice, it already autocompletes for me. So we want to see that the message sender is equal to the get approved of this token. There is one more case where you can approve someone, which is if you approve someone for all your tokens. So let me quickly write that one out. That's a little bit longer. Okay, so essentially this function will return whether the message sender is approved for all the tokens held by the old owner. All right, so I actually have ran a scan on this contract before with Mythax, and I'm gonna redo that scan on that particular contract with the message names that I use there, because Mythax is able to cache analysis results. And by doing that, I kind of speed up the results that we're able to get in this presentation. So this is the original contract that I talked about. And let's see, yeah, the same properties are here as well. And now what I can do is from my shell, I can run this command to analyze the smart contract with Mythax. So in this case, the Mythax CLI utility will be used, and it will automatically interact with Scribble for us and do everything that we need for the instrumentation, and then submit it to the Mythax CLI, Mythax platform for CI. Let me quickly post this here so it can be reposted. Yeah. All right. So Dimo will post this command in the chat so that you can copy paste it. The same command should be in the README as well. So even if you miss out on the chat, you can look back there and see what you need to execute. But really simple. This command, the first word is invoking the Mythax CLI. The second option is the output format. It's simple, which means that we'll get a nice output in the CLI that we can read. We'll analyze again. We'll use the standard mode, which means I think it will run for about 15 minutes and do fuzzing, symbolic execution, and static analysis to find violations. It will look for violations in this smart contract, the vulnerable Erc721 with the properties that we wrote. We have this option called check properties. This will make Mythax run in property checking mode, so you will not get all those generic findings, or I shouldn't say generic, but Mythax is a platform that also can find vulnerabilities that are not specifically related to any of the properties you wrote, and enabling this mode will make it so that those aren't reported, so that we just get the information we need on violated properties. The Scribble tag tells the Mythax CLI to look for annotations and do the instrumentation. And finally, we set the Sol C version so that it knows how to compile the smart contract. So let's run that. It will first take a bit to do the instrumentation, and then it will tell me that it has a job to submit. And for me, it should return within a second. If you do the analysis yourself, and maybe if I'll have time, I'll run it on my working example too, then it might take up to 15 minutes, and it will do a lot of analysis in that time. But you should be getting the same results. So here we see, again, 2 violations, 1 assertion failed event and 1 assert. And remember, this is because Scribble inserts 2 assertions by default, 1 assertion failed event and 1 assert false. That's for compatibility with other tools, because most tools are able to look for plain solidity assertions. But we see here that the property can't delete by sending to 0x0 is being violated. And let me quickly hop over to the Mythax dashboard and hope that the stream will allow me to do that, to show you the actual dashboard results, because there's some useful information in there. All right, so this is the report that you'll see for this analysis if you go to the Mythax dashboard, or at least this is what I'll see. So there's a little bit of non-determinism, so the coverage graph might be slightly different for you. But you see here the 2 findings again, the 2 assertion fails. Yeah, I should increase the font size here too. This should be better. Okay, so we have the two findings here, but we know about those two already. There's also a coverage graph here. So MythX uses fuzzing and symbolic execution in the backend, and those iteratively explore the different paths through a smart contract, which means that, like a test suite, they will cover more and more over time. And you see here how that coverage progresses and how it is able to cover more and more the more time it has to drill down into a smart contract. Now we can look into the instrumented file that was actually analyzed. And we see here on the left, we see green bars, and these indicate the very same coverage. These show us where the fuzzing and symbolic execution were able to reach. And if we go down a little bit into the actual ERC721 code, then we see that most of it was covered in this 15 minutes. If you have a very complex smart contract, you might need to use the MythX deep mode, which gives you, I think, 45 minutes of scan time. All right, but let me scroll down to the actual transfer from. And here we see the finding where there was a violation of the property can't delete by sending to 0x0. And what's nice here is that MythX can show you the actual trace that we found internally to violate the property. So here you see that the attacker minted a token and gave it to themselves, I think, and then sent it, which sends to the 0 address. And that is exactly what our property doesn't want and what would trigger a violation. So now what you could do technically is write a truffle test or hard hat test or whatever framework you prefer, and write these calls, and you should have the same violation. You can write a fix for the bug and then rerun this test or trace to see whether you actually fix the vulnerability, which I think is very useful. Okay. Let me move back to my editor again. Yes. All right. Can you? Oh, nice. Thanks. Okay. So there is a few more interesting things that we can do with Scribble. So I prepared a few examples where we can just highlight or easily highlight different capabilities of the Scribble language. I won't show you how to actually use Mithril or MythX to find violations of the properties here, because I don't think, or we didn't inject actual vulnerabilities here, so they should be correct. But yeah, let's just go. So I'm pretty sure that if you're familiar with smart contracts or Ethereum smart contracts, then you'll have definitely seen the use of the ownable pattern. The gist of it is there is one address stored in a smart contract, which is the owner, and there is privileged functions that only the owner can call. And these functions are protected by the modifier onlyOwner, which ensures that this is the case. Now, one thing that we can state about this in a so-called invariant is that we want to say that only the owner can actually change who the owner is, because we don't want just anyone to be able to overwrite ownership. So let me write that down. We'll use an invariant, which means that it should always be valid for every transaction. Owner can... Okay. So what we want to say is that if the owner changes, or what we can say is that if the owner changes, then for sure the sender during that time must have been the old owner. So let me write that down real quick. The old owner is not the new owner, means that the old owner was message sender. Okay. Now, this is actually not a valid property because ownership is a little bit more complex. Because during the constructor, we do change the owner from 0 to the sender of the transaction, as you'll see here, without the sender actually being the owner before. But the constructor is special because it can only happen once for a contract. So we'll say that if the owner is address 0, okay. So if the owner is not address 0, so if there is an actual owner set, which will always be the case, or should be the case after the constructor has set, has executed, and the owner changes, then we want to make sure that the old owner is actually the message sender. Now, there is another edge case in here because, oh no, I'm mistaken. So this will actually make sure that regardless of the code or arguments or functions that are in this entire contract or any contract that inherited, will always check or be sure that if the owner is changed from a non-zero address to another address, then the person doing that was the owner, which is nice because that's like the entire ownership pattern. All right, so we have 12 more minutes. Nice. Okay, so the other example I have is essentially just the very same as the one we started out with, but I just want to go ahead and fully annotate this Erc721 contract and show you how quick it actually is to take a contract like this and fully annotate it. Now, obviously, for more complex smart contracts, you need to think a lot more about the actual vulnerabilities that are in there, or the actual properties that are valid for that contract. So it might take a little bit longer there. But in this case, we have a simple Erc720, so we should be ready. Let's just go from the transfer function into the approve function. So the approve function, what it does is it will set an allowance so that some person, so the person calling the approve function allows another person or address to spend some amount of tokens, which is signified with a value argument. And it's the allowances mapping in this case that actually stores like this allowance. So what we want to check is that after the approve function succeeds, that the allowance of the spender for the owner is set equal to value. And this is a pretty straightforward property in this case, yes, but that's also because it's pretty simple code. So let me write this down real quick. Spender has we could copy paste, but I'm not going to do that. All right, so that's it. This function doesn't do anything else, so we can continue on from here. The next function is a transfer from function, and this is actually does pretty much the same as the transfer function, but it allows people to use their allowance to send tokens for somebody else. This means that we can take the properties that we wrote for the transfer function and just adapt them a little bit to match up with the parameters that are used in this transfer function. So instead of using the message sender, we use the from address. So this code put the transfer from function essentially is doing the exact same thing. We just need to replace things. So we can replace this with from. So from is not to, then to should receive the value. That's still true. Let's change this again. Sending to yourself or to someone self doesn't change the balance. Is also the same. Yep, that's still valid. Now we can adapt this from and to. All right, that's it. Now there are some more things that we can do because we want to maybe say that the allowance of the center of the transaction actually decreases with value if it succeeds. So allowance decreases with value. So the allowance of the sender is equal to the old allowance of the sender, but minus the value. We might also add another property saying that the sender should get value removed. We actually forgot to add that to the previous transfer function because we didn't really need it. In this case, we're talking about the from, and it's subtracted, not added. So that's it. That kind of specifies most of what we need, I think. That's actually something interesting to say before we wrap up. You can write a lot of properties and we can automatically check them. And maybe in the future, or probably, we'll write backends for Scribble that integrate with formal verification engines. And you can write a lot of properties, but the thing is that even though you might show that various properties aren't violated, you cannot show that properties you haven't written yet aren't violated. So essentially, if you don't write the property, you can't check it. let me move into the presentation so I can summarize all that we talked about. But the application is breaking for me. Okay. Yes. All right, so thanks. All right, in summary, we looked at a lot, even more than I had expected initially. We have function specifications using if succeeds, where you can talk about what a function is supposed to do if it succeeds. We have used the old keyword to both specify how a function changes state, but also to essentially write a precondition for an invariant to check that only owners can change the owner variable of an ownable contract. This is called implication. So that was the arrow with the two equal signs in there, where it's like logical implications, which essentially is a precondition, or kind of a precondition how we used it. We also used Mithril and MithX to automatically find violations of vulnerabilities, but also to see how the fuzzer and symbolic executor were actually able to violate a property, which you might use to write tests or automatically exploit smart contracts. But there is more. Keep an eye on the documentation and the GitHub repo, because there is a ton of work going into Scribble. There are some new language features dropping soon. And like I said, we're working on that integration with verification backends to bring more capabilities to you. Yeah, make sure to follow us on all the socials and keep up to date. With that, I'd like to thank you all for hanging out and following along. You can find us on Twitter there, and we also have a website with a blog where we release a lot of blog posts, and some of them are about Scribble. So if you're interested in security in general, or smart contract security in general, it's a really good place. But also if you're interested in Scribble, that's where we'll publish our main updates. And that's it. Stop screen sharing and move over to the chat to see if there are any questions.
Hey, Joran, can you hear me?
Yeah.
Yep. So it was a very great session from both of you. Hey, Dimo, you are here with me, right?
Yep, I'm here.
Yep. So it was a very awesome session from you all. We learned a lot about Scribble and properties. I got some responses from developers. They will be following the workshop after it will be recorded. And I've shared the MithX promo code as well. So, yep,
Cool.
Thanks for that as well. So people can follow along. So, any question? We still have 1 or 2 minutes. You can take questions if there are any.
Both me and Dimo are on the Discord as well, so If there are questions after, you can ping us there.
Okay, yep. I will share the link. Share your profiles for the Discord and Twitter as well, so they can catch up with you. So all good. Any point that you want to add for the ending session?
Nope.
Timo, it's all good.
Nope, that's all good. Joran had everything covered.
Yeah,
So-
thanks for having us.
Yeah, thank you all for being with us, our speaker for the Unchained Blockchain Security Conference. It was a nice pleasure meeting you all and having you with us. So there's a comment saying this was long but interesting stream.
Thanks. All right.
All right. So see you, Joran. See you, Timo. We'll see you on the next event. Bye-bye.
Thank you for your time.